Hello everyone, welcome to another video on maths. In this video I'm going to be focusing on sequences and series. This is lesson 1. We have had a baseline assessment on this one. I took some time to go through 2 questions, but now I want to start this topic in detail with regards to high school curriculum. So let's start then with arithmetic sequences, because there are 3 types of sequences and series we're going to focus on: arithmetic, geometric, and quadratic. Let's start with arithmetic, also known as linear sequences and series. So I'm going to say here 1.1, and I'm talking about arithmetic sequences and series. So we start with the definition then. We define an arithmetic sequence as a sequence of numbers in which each new term is obtained by adding a constant value This constant value is known as common difference to the previous term. So an arithmetic sequence is a sequence of numbers in which each new term is obtained by adding a constant value known as common difference to the previous term. That's the definition of an arithmetic sequence. Let's look at examples now. Examples, just gonna give a few. First example, number 1 would be 3, 7, 11, 15, 19, 23. You can continue. Notice something here, that to obtain 7 you add 4 to this term here, to 3, which is the previous term, to 7, and then you must continue adding 4 as you go. So 3 plus 4 7, 7 plus 4 11, 11 plus 4 15, plus 4 19, plus 4 23, and so on. So this qualifies to be an arithmetic sequence because each new term is obtained by adding a constant value to the previous term. In this case, our constant value is 4. So this is an example of an increasing sequence. But we can also have an example of a decreasing sequence. For example, 102, and then we have 100, we have 98, we have 96, 94, 92, and you can continue. Notice something here. Each new term is obtained by adding a constant value to the previous term. To obtain this, I must add minus 2 to this. Basically, subtract 2 from that. But using the definition, I'm adding minus 2 to that to get this, add minus 2 to that to get this, add minus 2, and so on. So in this case, the common difference is minus 2, an example of a decreasing sequence. Let's look at example number 3 here, what we call a constant sequence. So you can have 7, 7, 7, 7, and so on. Notice that here, to obtain the next value, I just add 0 to the previous term. So in this case, our common difference is 0. Now, these are very simple sequences, but I can give you another one, number 4, where the common difference is not so much a whole number. You can have, for example, 2, and then you have 3.5. So you can see here I'm adding 1.5. And if I add 1.5 to this, I'm going to get 5. If I add 1.5 to this, I'm going to get 6.5. If I add 1.5 to this, I'm going to get 8. If I add 1.5 to that, I'm going to get 9.5 or 9.5, and so on. So the common difference doesn't have to be a whole number. It can be any number. So these are just examples of what we call arithmetic sequences or linear sequences. Right, so the examples given. What I want us to look at now is what we call the general term, the nth term. We want to be able to generalize, describe every term here by using a formula. So I'm going straight to the general term. Go to page 2. Page 2. And in page 2, perhaps let me go through terminology first before we move on to the general term. Let's look at the terminology. In other words, some of the constants we're going to be using. Terminology. When we talk about terminology, we're referring to stuff like what is the first term represented by. First term is given small letter a. The common difference we spoke about in the definition is represented by letter D. The position of a term or number of terms is represented by small letter n. That's 1, 2, 3. Let's go to number 4. The nth term is represented by T subscript n. The sum of the first n terms is represented by S subscript n. Notice that the nth term is also sometimes known as last terms, capital L. So these are the symbols we use, and also let's just make sure that we understand that n here, this n here, number of terms or position of a term, must be a natural number. So it must be a natural number there. Whereas the common difference, the first term can be any number. That's the terminology. These are the symbols we're going to be using. I would want now to move on to talk about what we call, so terminology sorted. I want to now talk about what we call the general term. General term, also known as nth term formula. Now, we want to be able to generalize any arithmetic sequence given by using a formula in terms of how do we determine term at position 100 or at position 1000. I don't have to write out the entire sequence until I reach term number 1000. I can work it out by using a formula. So that's what we want to do now. So let's look at the general. Consider the general arithmetic sequence. This we obtain it by using the definition. What is an arithmetic sequence? We defined it as a sequence of numbers in which each new term is obtained by adding a constant value to the previous term. So by using that definition, we can actually say that the general arithmetic sequence, and of course considering our terminology here, we can say our first term is A. That's our term number 1, T1. Term number 2 will be a plus the common difference d. Term number 3 will be, notice, a plus 2d, because we're adding d to each term. Add d here, add d, add d. You're going to get term number 4. It's going to be a plus 3d. That's term number 4. And you can continue. So this is our general arithmetic sequence. And I want to look at analysis of this. Of course, our interest is, what is this term at position n? The last term there at position n. Term at position n. I want to look at term at position n. So this is term number 1, number 2, number 3, number 4, and so on. So let's look at analysis of this then. So analysis, I'm going to call it. We're on page 3 now. Analysis. Analysis of what? We're talking about position. We're talking about term. And then we are going to have what I call magic here. I'm going to explain to you why I call it magic. So term number 1, term number 2, term number 3, term number 4, and I'm going to say do, and then term number n, term at position n. So term number 1, we know it's a. Term number 2, it's a plus d. Term number 3, it's a plus 2d. Term number 4, it's a plus 3d. Term number n, it's tn. We want to know what tn is. Now, here is the magic part. I can write this a as a plus. So let me just do this. I can write this a as a plus. Watch this. 1 minus 1 times d. Obviously, 1 minus 1, the answer is 0, times d, the answer is 0. 0 plus a, we're still having a. This term here, I can write it as, check this, I can write it as a plus 2 minus 1 times d. Obviously, 2 minus 1 is 1 times d is d plus a plus d. This term here, I can write it as, watch this, a plus 3 minus 1 times d. Obviously, 3 minus 1 is 2 times d, 2d. A plus 2d, a plus 2d. This term here, I can write it as, watch this, a plus 4 minus 1 times d. And obviously, 4 minus 1 is 3 times d, is 3d, a plus 3d, which is what we have there. The question is, where are these numbers coming from? And the answer is as follows. The 1, look at this, 1, 2, 3, 4, it's the position of each term. So that 1 there is that 1 there. And that 2 there is that 2 there. And that 3 there, obviously, is that 3 there. And that 4 there is that 4 there. We know what a is, our first term. We know what d is, our common difference. But where is this one coming from? The one that is always subtracting. The answer is that one there is the difference in position. So 2 minus 1, it's 1. 3 minus 2, it's 1. 4 minus 3, it's 1. That's why that one must appear everywhere, because the difference in positions is always, we're talking about consecutive positions, it's always 1. That's why you have this one here at the end, that one there at the end, subtracting. It must always be there because the difference between any two consecutive terms, positions, is 1. Now, from here, you can agree with me that therefore this can be generalized as follows. We can say that will be, let me write it in red, that one. That will be a plus n minus 1, and obviously you must have a d there. That's how we are saying the number of terms, the nth term formula or expression is actually a plus n minus 1 times our common difference. So this is where it comes from. All right, let me put this one in a rectangle because we are going to need this one. Here we go. We're going to need this one. That's the nth term formula obtained from the general arithmetic sequence, right? From this general arithmetic sequence here, a plus d, a plus 2d, and so on, obtained from the definition. What did we say is an arithmetic sequence? a sequence of numbers in which each new term is obtained by adding a constant value to the previous term, and that constant value is known as a common difference. So that's our D that we're adding each time. So that's our nth term formula. Now I want to look at examples applying this nth term formula so that we understand how to apply it. All right. So, and I'm going to look at just maybe 2 examples. Let's look at examples here. Number 1, consider the following arithmetic sequence. Following arithmetic sequence. Our sequence is 2, 5, I'm adding 3 as you can see, 8, 11, and then we have 14, and then we have 3 dots here, and the last term we want to stop at is 1199. That's where I want to stop. Now the question is determine, so I'm going to have A, determine one, the number of terms, or nth term expression first. The nth term expression or formula. Sometimes some books will say nth term formula. Right, let's look at number 2. We're on page 4 now. Number 2, what are we supposed to determine? Well, the number of terms. The number of terms. Let's look at number 3. What are we supposed to determine? Number 3, which term 299 is? Determine which term 299 is. Number 4, we're going to say the number of terms that are not divisible by 5. Number 4, the number of terms that are not divisible by 5. That's up to 4, and then I'm gonna say maybe we need one more. Let's go to B. Number B, it says let's just give a nice simple one here. Show that 400 is not a term of this sequence. Just up to there, let's go through this. We have one more question that we have to deal with, a little bit more involving, but let's go through this. Now, notice what we have here now. We have a sequence 2, 5, 8, 11, 14, and so on, all the way up to 1199. That's 1199. We're required to determine the nth term expression or formula. So my answers will be as follows. This is example number 1, obviously, and we're dealing with A1. Let's capture this the sequence. We're dealing with 2, 5, 8, 11, 14, 1, 2, 3 here, all the way up to 1199. Right. Now, So the nth term formula, our first term we know is 2. Our common difference, we can work it out. It's 5 minus 2, and the answer is 3. The formula says T subscript n is A plus n minus 1 times D. What is A? There is our A is 2 plus, because they're saying we must find nth term formula or expression, we know our answer must contain n. What's our common difference? 3. Let's simplify this. This is 2 plus, expand that, 3n minus 3. And you'll agree with me that this is 3n minus 1, because 2 minus 3 is minus 1. So T sub n or subscript n equals 3n minus 1 is the nth term formula that the question requires us to determine. In other words, using this formula, we can describe each and every term in the sequence. For example, term number 1, if you put 1 here, it will be 3 times 1, 3 minus 1, 2. Term number 2, put 2 here. 3 times 2, 6 minus 1, 5. Term number 3, put 3 here. 3 times 3, 9 minus 1, 8, and so on. Right, so this is why it's called a general term, because it can describe every term in the sequence. Now we're done with number 1A1. Now we're moving on to number 1A2. What is number 1A2 saying? The number of terms. In other words, at which position is 1199? So we are going to equate that number to this one now to determine n. Right, so let's go to the next page now. Can you see it there? Yes, you can. So now we're saying number 2, in order to determine the number of terms, we're going to say our last term. Remember I told you that when I was looking at terminology, and I like to remind students as I move along. We said nth term is last term, and if you look at the sequence given here, what is our last term? Our last term is 1199. That's why I said in order to find out at which position this number is, we must take this number equal to that and determine the value of n. So this is going to be equal to 1199. And what is this? It's 3n minus 1. We say this equals 1199. Then add 1 on both sides. We're going to get 3n, because if you add 1 here, I think it's 1200. Just check on the calculator here to be on the safe side. 1199 plus 1. Yeah, 1200. That's correct. 1200. And therefore, to determine the value of n, we divide both sides by 3. So we're going to get n being equal to, or let's just be like this. Let's just be careful here. This is what we're saying. This cancel. What is our n? It's going to be 3 into 12 is 4. So its n is actually 400. Am I done it correctly? Divide by 3. Yes, n is 400. So there are 400 terms in the sequence. The question is saying the number of terms, n. Remember on our terminology, we said n is the number of terms. We said n is the number of terms. Here we go. N is the position of a term, or number of terms is n, which is a natural number. And this condition is very critical there, that n must be a natural number. You will see that some examiners require you to know that n is a natural number. So you will have a question that is actually aimed at finding out whether you know that n is a natural number or not. We do have it in this in example 1 that we have, this last one here. All right, now let's move on to the next question. The next question here says which term 299 is. At which position is 299, or which term is 299? Again, the same thing. Number 3, what we're going to do is we're going to say T subscript n equals 299, and then what do we say? This is 3n minus 1 equals 299. Add 1 on both sides. 3n equals 300. Divide by n both sides by 3 both sides. N equals 100. Then we are going to say, therefore, 299 is the 100th term. Take note of that. Right, let's look at number 4. What is number 4 saying? It says the number of terms that are not divisible by 5. The complementary rule again coming up I spoke about this in the baseline assessment. Whenever you see not, you know you are going to take the indirect route. Find the total number of terms, which we have already obtained here. It's 400. The total number of terms is 400. Here it is. Now we must work out the number of terms that are divisible by 5. And then we're going to subtract from this to determine the number of terms that are not divisible by 5. So therefore, what I'm going to need to do now is to write out that's number, if you check number 4, number 1A4. So number 1A4, our solution will be set out as follows. Question 1A4, we have to write out as many terms as we can. So we have the sequence 2, 5, 8. I'm adding 3, remember. Here it is actually. It's 2, 5, 8, 11, and so on. I constantly add 3. So this is going to be 11 plus 3. It's 14 plus 3 is 17 plus 3, 20 plus 3, 23 plus 3, 26, 29, 32, 35. You can clearly see there that we are now beginning to see the terms that are divisible by 5. We have, let me use a red pen here. We have this term here, divisible by 5. The next term is this one. The next term is that one. Our job now is determining the last term. Is this last term divisible by 5? The answer is no. So this cannot be our last term. We're talking about terms divisible by 5. So what do we do? In the baseline assessment, if you remember, I told you that the common difference, if you want to find the term before this, you must subtract the common difference. And then divide by 5 to check if the number is divisible by 5 or not. If it's not, continue subtracting and dividing to check. So we are saying here 1199. The common difference is 4 according it's 3 actually in this one, because we're adding 3 each time. So subtract 3. What is the answer? It's 1196, not divisible by 5, because the last digit is not divisible by 5. Subtract 3 again. 1193, not divisible by 5. Subtract 3. 1190. That one now is divisible by 5. So our last term is 1190. So we are saying, therefore, sequence of terms divisible by 5 is, our first term is 5, second term is 20, 35. We can continue all the way up to 1190. We want to work out how many terms we have here. So we know our first term is 5. Our common difference is actually 20 minus 5. This number minus that number. The answer is 15. You find the same by subtracting 20 from 35. So we're sure this is an arithmetic sequence. Do we know our last term? T subscript n is 1190. We want to find number of terms, remember? So the formula says T subscript n is a plus n minus 1 times the common difference. This must be equal to 1190. Do we know a? Yes, a is 5. There it is. Number of terms we don't know. Do we know the common difference? Yes, it's 15. There it is equal to 1190. What do we do next? Subtract 5, this number, from both sides. Most learners like expanding this and they make mistakes. If you check in my baseline, I never expanded that. I just got rid of that, and I got rid of that using the inverse operation principles. So the inverse operation of addition is subtraction. So we subtract 5 from both sides. So what we have is n minus 1 times 15. And the answer is 5 from that number. It's supposed to be 1185 minus 5, 1185. That's 1185. What is the inverse operation of multiply by 15? The answer is divide by 15. So I divide by 15 both sides. On the left, I get n minus 1. On the right, I get 1185 divided by 15. My calculator says 79. And then inverse operation of minus 1, I add 1. So I add 1 on both sides. I get n equals 80. Now, there are 80 terms in this sequence. there are 80 terms in this sequence that are divisible by 5, but there are 400 terms in total. Here it is. So how many terms are not divisible by 5? So we are saying basically complementary rule. We're saying T all terms is equal to, I want to use T here for all terms, but I can also use number of all terms. So let me use small letter n, because we're dealing with n here, not so much T. For some we use S sub all terms. Now in this case we're using n. So n all terms, number of terms, all terms basically, equals n for terms div by 5 plus number of terms not div by 5. What is this? 400 is equal to, what is this terms divided by 5? 80. Remember n total 400, and then what we want is this n not div by 5. So this is what we're interested in. So you will see that we are just subtracting here. So we're basically saying, therefore, number of terms not divisible by 5 the answer will just be equal to 400 minus 80. I think this is exactly 320. So there are 320 terms that are not divisible by 5. Let me just check here. 400 minus 80, obviously it's 320. That's right. So let's go to number B then. What is number B saying? Example B. Example 1B. Example 1B, here it is. Number 1B, show that 400 is not a term of this sequence. So whenever you have this kind of equation, show that means prove that 400 is not a term. We prove this by contradiction. We assume it is a term and show that it is not. So proof, I'm going to write here by contradiction. And we assume 400 is a term of the sequence. And show that it is not, because the assumption disagrees with an already known fact. The assumption disagrees with an already known fact. In this case, the already known fact is that n is a natural number. So let's see. Therefore, we can say, we know that t subscript n, we found it as 3n minus 1. 3n minus 1. Because we're assuming 400 is a term, we equate this to 400. And what do we get? We get 3n equals 401 if you add 1 on both sides. And what is n equal to? Divide by 3 both sides. 401 divided by 3. My calculator says 133.67. 133.67. And you see that this is not a natural number. But we know, we said it under terminology, that n must be a natural number. So therefore, this already known fact is contradicted by that assumption that 400 is a term. So we're going to say, therefore, we say, but n is a natural number. Therefore, 400 is not a term. This is what we call proof by contradiction. Right, this is 35 minutes. Let's look at example number 2. And example number 2, I would like to just put up a question that requires us to solve. And I'm going to say the 19th term, example number 2, and this will be the last one in this video. Number 2, the 19th term of an arithmetic sequence is 4 times the 5th term. Full stop. The 16th term exceeds the 8th term by 24. The question says determine the 100th term. This is what we have. So it says the 19th term of an arithmetic sequence is 4 times the 5th term, and the 16th term exceeds the 8th term by 24. Determine the 100th term. So this is a typical case where you have to form simultaneous equations and solve them. Let's go straight into it. Our answer will be as follows. First, translating the information as it is, 19th term, T19, is equal to 4 times term number 5. There it is. And we know that T subscript n is A, n minus 1, D. So therefore we can work out T19 from here. T19 will be equal to A, which we don't know, 19 minus 1 times D. What do we get here? We get A plus 18D. We're done with this part. Let's come here now. What about term number 5? It's going to be A plus 5 minus 1. Remember, we're substituting the number of terms. This is number of terms we put here and there to obtain that expression. And then we're going to take 5, put it here and there to obtain this expression here, which is just A plus 4D. Now we take these two terms or two expressions, put them here and there. So we're going to say now, on the next page, we're going to say, I put it somewhere here, this is page number 9. And I move this one down a little bit so you're able to see everything. Right. So we're basically saying, therefore, T19 equals 45 becomes, that equation must become, this expression must come here. A plus 18D equals 4 times what is T5? Well, T5 is A plus 4D. A plus 4D. Expand that, let's simplify the equation. So A plus 18D is equal to 4A plus 16D. Bring these two terms to the left. A minus 4A is minus 3A plus 18D minus 16D is 2D, and we have 0 there. Let's call this equation number 1. We're done with the first part. Which part? The 19th term of an arithmetic sequence is 4 times the 5th term, full stop. Now we're analyzing it from there. The 16th term exceeds the 8th term by 24. Most learners struggle to understand this. It is basically saying that term number 16 is bigger than this term by that much. So it means when I add term number 8, I add 24 to term number 8, I should find term number number 16. Or if I subtract 24 from term number 16, it should give me that. Please just try and understand what I'm trying to say here. Term number 16 exceeds that term by that much. Let me give just a simple example so that you understand what I'm trying to say. Just two numbers. If I put two numbers and I say 35 and I say 30, we're saying this term exceeds that by 5. It means two things. Either I must add 5 here and then I get that, or subtract 5 from there to get this. So this term exceeds that by 5. If I add 5 here, I get this. I subtract 5 here, I get that. So if the question says term number 16 exceeds term number 8 by 24, I either add 24 to this to get that, or I subtract 24 from there to get this one. So we are now saying also term number 16 exceeds term number 8 by 24. If you allow me to go straight into substitution into this formula here, I'm going to say this is the same as a plus 16 minus 1 times d is equal to, this is a plus 8 minus 1 times d plus 24. Now this is a plus 15d is equal to a plus 7d equals, sorry, plus 24. Plus 24 there. Right, so I'm going to come and fix that. Plus 24. That must be plus. Notice that the a is cancelled. 7 must come here. So 15d minus 7d. What is the answer? There's 24 left this side. Remember, there's a plus sign here. I'm going to fix it. This is 8d equals 24. What is d equal to? Divide by 8 both sides. D equals 3. Now that we know what d is, we go back into equation number 1. We can call this equation number 2. And we put or sub equation number 2 into equation number 1 to get, remember, equation number 1 is minus 3a plus 2, our d is 3, and this equals 0. Let me not forget this part here. This has to be plus. And solving this, we'll move on to the next page. Solving that, and I think I'm going to need just about this space here. It's sufficient. Solving that equation, we're going to get, yeah, you can see, we're going to get minus 3a equals minus 6, if you like. And so a equals 2. When you divide both sides by minus 3, get a equals 2. But the question is not saying we must find the first term and the common difference. The question is saying determine the 100th term. Here it is. Determine term number 100. So now we have been given n. We know our first term is, we calculated it. Where is our first term? A is 2 and our common difference is 3. So we can basically say t subscript n is a, n minus 1 d. Therefore term number 100 will be equal to, what is a? 2 plus 100 minus 1. What is d? 3. Calculated up there. This punching this into calculator, that's 97. Sorry, 99 times 3. It's supposed to be 99 times 3 plus 1. 99 times 3 plus 2, sorry. Plus 2. 99 times 3 plus 2. My calculator says 299. Of course, you would recall that here I'm just playing with your mind. It's the same sequence that I've been dealing with. And we saw that term number 100 was actually 299. The question was saying which term is 299. Let me just go back a little bit to show you what I'm talking about. Do I have that page here close to me? Which term is, there it is. Term number 100 is 299. So basically it's the same sequence that I've been playing around with up to this far. This is just the first part of lesson 1, or I mean first part of sequence and series. I'm coming back with lesson 2. We will look at the sum of the first n terms, and then continue with practical questions, in other words, real life questions, real life problems, and then we'll move on to geometric sequence and series, and then we'll finally end up with quadratic sequence and series, right? Practice makes perfect. If you're new to this channel, please support us by subscribing and or inviting friends to subscribe, sharing these videos, providing comments in the comment section below. We value your feedback. I try my very best to respond to every comment or every clarity seeking question. Yeah, so practice, 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 practice. The more you practice, the better you get as far as math is concerned, because mathematics is a skill. You cannot obtain a skill in a day. It requires time, and you must not give up. It get tough in some cases, but when the going gets tough, the tough get going, as they say. All right, I'll see you next time.